In August 1977, researchers operating the Big Ear radio telescope at Ohio State University were staring into the deep sky, listening intently to one very specific frequency, 1420 megahertz. They chose this frequency for a very logical reason. Hydrogen is the most abundant element in the universe, and it naturally emits radio waves at exactly 1420 megahertz. Scientists hypothesized that any intelligent civilization trying to broadcast their presence across the galaxy would use this specific frequency as a universal hailing channel. Then, on August 15th, the Big Ear detected something staggering. A massive, concentrated radio burst hit the receiver, blasting exactly on that 1420 megahertz hydrogen line for 72 straight seconds. This is the original data printout from that night. When astronomer Jerry Ehman reviewed the numbers a few days later, he was so stunned by the intensity of the reading that he grabbed a right pen, circled the sequence 6EQUJ5, and scribbled "wow" in the margin. That specific alphanumeric sequence is mathematical proof of the signal's profile. Big Ear recorded intensity on a scale starting with numbers, then moving into letters for higher values. The sequence jumps from numbers up to the letter U, indicating a peak intensity 30 times louder than the background noise of space, and then drops perfectly back down. It was an intense, narrow-band, pinpoint source. These are the exact hallmarks you would expect from an engineered artificial beacon. They noticed that during the summer of 1977, two comets, Christensen and Gibbs, were transiting through the exact region of the sky Big Ear was observing. The logic seemed solid. As comets travel, they shed massive clouds of hydrogen gas. The theory suggested that this enormous envelope of trailing gas could generate a noticeable radio signature right on the 1420 megahertz frequency. But cometary hydrogen is diffuse and weak, creating a low-intensity hum. The wow signal was a highly concentrated point source. Furthermore, Big Ear used a dual-horn feed system. A comet would register in both horns minutes apart. The wow signal hit only one. The comet hypothesis collapsed. Astrophysicists needed a natural mechanism capable of generating immense, tightly focused energy in a single solitary flash. The answer arrived in 2024. A team of astronomers dug deep into archival data collected by the Arecibo Observatory in Puerto Rico, and they discovered what they called mini-wow signals. These new signals carried the exact same narrow-band profile as the 1977 event, and researchers traced them directly to ordinary, cold interstellar hydrogen clouds. The only difference was that these modern signals were incredibly faint. This presented a new physics problem. How does a faint, lazy cloud of space gas suddenly ignite into a deafening radio beacon? This sudden energy surge requires a specific cosmic trigger, a magnetar. These are ultra-dense, highly magnetic dead stars, prone to violent, high-energy outbursts. A magnetar eruption triggers a spectacular reaction when perfectly aligned behind a cold hydrogen cloud and Earth's telescope. The extreme radiation pumps the hydrogen atoms into an unstable state, triggering superradiance. This amplifies the frequency, blasting a concentrated radio laser directly toward Earth. This natural microwave laser accounts for every single anomaly recorded in 1977. It produces the massive intensity, it fits the impossibly narrow bandwidth, and because it relies on a fleeting stellar flare, it explains the brief 72-second duration. Astronomers in 1977 lacked the theoretical framework to identify this source. Magnetars wouldn't even be hypothesized for another 15 years, and at the time, the idea that a simple gas cloud could amplify a signal to this degree was unknown. And the reason the wow signal has never repeated is simply a matter of absurdly rare probability. It requires a 1 in a million, three-dimensional alignment of a listening telescope, an interstellar gas cloud, and a completely unpredictable stellar flare, all flashing in the same instant. Identifying this mechanism equips the modern search for extraterrestrial intelligence with a vital new filter. Astronomers now know exactly what a natural superradiance event looks like, allowing them to isolate these false positives when analyzing future data. While it may be disappointing to remove a prime candidate for an alien transmission, the discovery reveals a different kind of milestone. It shows that the natural universe can align forces to create a signal that perfectly mimicked a technological beacon.